All right, so we are going to go ahead and go through Unit 1, Section 4, zeros, positive and negative function values. And this is pretty straightforward if you understand the increase and decreasing max and min stuff that we have already done. So learning targets, we are going to be finding the real zeros for a function, worry about the non-real or the complex later. We're going to find intervals for positive or negative function. Find intervals, oops, that doesn't make sense. Find the positive or negative intervals for a function. That would make a little more sense. There we go. All right, so a couple definitions here. So we're going to define the zeros. A zero of a function is a place where the height of the graph is 0. Okay. In other words, the y value or the output at that particular place is equal to 0. Okay. So those are called zeros. They can also be called roots. They can also be x-intercepts. They are comparable to x-intercepts. So when you find the x-intercepts, you're replacing y with 0. So that's how you do it. You simply replace y with 0, and you are guaranteed to have an x-intercept, assuming that you get a real 0. So that's very important right there. Okay. Now, notice that there are intervals. So when you have zeros, so at this 0, all of these are zeros here, here, and here. Before a 0, if you're positive, greater than 0, that would mean that after the 0, it could change to be negative, and then at the next 0 it does that, and it just keeps going back and forth in theory. So a function is positive on the intervals, okay, where the graph is above the x-axis, negative on the intervals where the graph is below the x-axis, okay? Positive is above, negative we are below. All right, moving forward. So let me go through a few different graphs. Let me show you this Desmos, just so you can kind of see what we're dealing with here. So when you have a polynomial function, these are parent functions, right? So this is y equals x to the first, this is y equals x to the second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11th, 12th. So as you keep going, you should see a pretty straightforward pattern. It just goes back and forth, right? So these are odd. 1, skip 2, go to 3. Skip 4, go to 5, odd, skip 5, 6, go to 7, skip 7, skip 8, go to 9, skip 10, go to 11. So all of the odd have a very similar shape, and all the even as well, 2, and 4, and 6, etc., etc. So what that means, if you think of those graphs that we just talked about, is that if you have a odd degree, is what we would say, right? So this is an odd degree. This is x plus 3 to the first power. You're going to have a root at negative 3 because if you have this equals 0, x would have to be negative 3. Okay, it's odd. That means it's a first power, first degree, you would say. And the behavior of the graph is that it just strictly passes through the x-axis. It starts at the bottom, crosses at a single point, goes through. Now let me skip to the, then the other odd ones. So the other odd ones, x minus 1 to the third power, okay? So that means the x-intercept, or the 0, or the root, is going to be based on the fact that x equals 1, okay? Now odd, 3, 5, 7, anything that's an odd number for that exponent right there is going to wiggle through, okay? Or you could say that there's a change in concavity. That's what you'll talk about a little bit more when you get to calculus. Change in concavity. So that's what we saw when we saw any of these odd ones, right? So if you have some, and the bigger the odd number, the flatter. So that's x to the 9th, that's x to the 11th. So it just kind of almost looks like a 90-degree angle at that particular place where it crosses through the x-axis. So moving forward then. Now even is very much like odd, except for instead of going in quadrants 1 and 3, it's in quadrants 1 and 2. So x squared, that's an even number, right there, even degree. And this has a x-intercept at 0, or root at 0, and either bounces or touches, okay, you could say. Now it could also cross the x-axis, at 2 places, but in this case it bounces. But it has that general shape is kind of what we're looking at there. Okay, even it bounces or it touches there. So even if you hit the x-axis, you don't have to go through it. And And then x plus 2 to the fourth, that's an even number, it's larger. If x plus 2 were to equal 0, we would have an x-intercept of -2. So that's even. The higher the degree, the flatter the bounce is as you look across it like that. All right, so for each of these graphs below, what I want you to do is find their zeros, given the graphs, and their multiplicity. So multiplicity is basically what we just talked about, right? Multiplicity is up here of either 1 because it's odd, 3, 5, 7, etc. because it's odd, 2 because it's even, 4 because it's even, right? Now, if you don't know what number it is, but you know that it's even, you can just go ahead and pick a 2. Okay, so what we're going to do is we are going to write down the zeros, okay, and their multiplicities. We're going to write a possible factorization of the given polynomial. We're going to identify the intervals for positive and negative values for that particular polynomial. All right, so let's start with, okay, the first one here. So the information that matters, what's most important about this, if you look at it, is that you'll see that the x-intercepts are at -3, okay? So we have -3 for x, 0 for y. We have 1, 0, and we have 4, 0. And all three of these x-intercepts are simple, straight pass-throughs. There's no squiggle, no bounce, nothing like that. So what we can do is we can go ahead and say that the zeros are going to be -3, 1, 4. Okay? So when we write the zeros, here's the way we do it, okay? Zeros, -1, -3, and since it passes straight through, that's a multiplicity of 1. -3, multiplicity 1, comma, then we're going to do 1, also multiplicity 1, and the last one is a 4, and that is also multiplicity 1. So we have a total multiplicity value of 1, 1, 1, which adds up to 3, okay? So when you have a multiplicity total of 3, that means we're going to write 3 factors, okay? So here's a possible factorization of the function. We'll call it f of x, okay? So we have x plus 3 based on that 0 to the first. We have x minus 1 to the first. And we have x minus 4 to the first. So each of the zeros and their multiplicity contribute some factors, all right? Positive and negative. Let's do, we'll do positive as green. So it's positive from, here, I'll tell you what. I'm just going to draw on the bottom here. From -3, that x-intercept, over to 1, that x-intercept. That's a positive interval. Red for negative. Negative interval between -1 and 4. That's a negative interval. And then it's positive from that point to infinity. Positive. Okay. Then on the left side, it's negative from -3 going towards infinity. Okay. So my values were -3, 1, and 4. So positive intervals are going to be from -3 to 1. So I'm going to do it like this. It's a parentheses because it's not positive or negative at a nor negative at an x-intercept. So we're going to do -3, 1, -3, comma 1, union, right? And then we'll do the next positive intervals from 4 to infinity. Okay. Negative intervals are going to be from -infinity to -3, union, and then we'll do 1 to 4. And that's it, okay? And you'll notice that between both intervals, we go from -infinity to +infinity. So that means we've included everything because that actually would be the domain of that particular function. All right, okay, let's try one more like that before we move on here. Extend the page a little bit. All right, so let's go through and look at this one. So on this one, we have -2, but it's a bounce. So we're going to think about that. We have 1, that's a straight through, not a bounce, and 3, which is also a straight through. So you have 3 x-intercepts, however, the -2 has to be expressed as a multiplicity of 2. It could be multiplicity of 4, 6, 8, but we're going to go ahead and go with the smallest even number that we can do. Sometimes we'll say what's the minimum degree, and we say minimum degree, that's what we mean. So my zeros are -2, I'm going to go with multiplicity 2. I'm going to do a 1, multiplicity 1, because because it goes straight through. So the shape of the x-intercept tells you the multiplicity. And then a 3 is multiplicity 1. Okay, factorization, f of x equals, so for this one I'm going to do x plus 2 squared. Multiplicity 2 means you square it. Okay, times x minus 1 to the first times x minus 3 also to the first. So all together, you'll notice the degree is 2, 1, 1. So the degree is the total multiplicity, which in this case is 2 plus 1 plus 1. So that would be 5, 5th degree. And that is a wait a minute, I did that wrong. 2 plus 1, not 5. Of course, what a ridiculous statement. 4, thank you. All right, to myself. All right, then finally, let's look at, so it's going to be at -2, 1, 3. Okay, so it's positive from -infinity to there. It's positive, it just bounces off, so it stays positive to there. And it becomes negative, so we got positive and positive. And then it becomes negative, where we got positive, positive. And then it's negative here, and then it's positive again once you go over here towards infinity. All right, so positive intervals are -infinity to -2. And here's where you gotta be careful, because it does skip -2. At -2, it's not positive nor is it negative. Okay, so you gotta do the union to specify that you skip over that. And then between -2 and 1, it's positive still. And then finally, the only other positive interval would be from what? 3 to infinity. Okay, so that's my positive interval right there. Here, let me fix that. There we go. Okay, so there's my positive interval. Okay, negative interval is going to be, the only interval that's negative is between 1 and 3. So that's just going to be from 1 to 3. That's it. And that's the only interval that would have been missing from the first answer, the positive interval. All right. So if you wanted to then, as we go through this, one more example here that we'll go through, and then we will move on. Okay, so the next thing we'll do is look at using a graphing calculator or Desmos to be able to do this as well. So if I do, all right, so we'll pick up there in just a minute. All right, so let's go ahead and do this one last example. So if you look at this graph, I'm just going to go ahead and isolate or highlight the x-intercepts, the positive real numbers. So it looks like we have a bounce here at -2. We have a cross through, straight through at -1. And we have this wiggle thing right here, okay, at 1, 0. Yeah, that's what that says, 1, 0. So we have to be careful because we have 3 different types of multiplicity here. So the -2, so first we have zeros. So the zeros are -2, and based on the fact that it bounces, okay, -2 is multiplicity even, which we're going to go ahead and just say that's 2. And then at -1, it's multiplicity 1 because it just crosses straight through. There's nothing special or different about that. Now at +1, that's what it looks like when you have an odd. So we're going to use 3 as the smallest odd number we can use. So we have 3 different multiplicities here. So my function is going to look like this. Okay, we're going to have f of x equals, we're going to do x plus 2 is a factor, and it's squared because it's multiplicity 2, times, and then x plus 1 is a factor because that's the 0, multiplicity 1. So we're just going to put a 1 there. You don't have to put a 1 there, but you could. And then x minus 1, we're going to do multiplicity 3, so that's going to be cubed. So notice that the powers, the squared, we can put a first there, a 3 there, all together, the multiplicities add up to what the degree should be. So the degree is 2, 1, 3. That would be a total of 6. That's even. And if you look at the graph, it behaves a lot like an even would, okay? It almost just looks like that shape. Now it does some other stuff in between, but on the left and the right side, it definitely just goes down and down. All right, now let's go ahead and isolate the different intervals of positive and negative. So it starts out as being, here, let going to do a number line on top like this. Okay, and I'm just going to put the important points there. We have -2. We have 1, -1. We have +1. We have, that's it. Okay, so those are the 3 places where something happens. So it looks like it is negative, negative here till we get to -2. And then it stays negative until we get to -1. And it's positive as you go from -1 to 1. Positive. And then it becomes negative again from 1 and then towards infinity like that. All right, so my intervals are positive interval. There is only one, and it's between -1 and 1. The negative interval, there's going to be 3 separate intervals that are going to be negative there. Okay, and then, so I'm going to go ahead and write those down. So the negative intervals are going to be from -infinity to -2. Skip -2 because there is a 0 there. And then pick up on the other side, -2 to -1. And then finally, we're going to have 1 to infinity, just like that. All right, so there's my negative intervals. Okay, so now that we've done that, now we can go ahead and we'll use graphing calculator to figure out what the x-intercepts or the zeros are. It's a pretty straightforward process, but I just want to make sure that you are aware of how you should do that. Okay, so the only other thing that I wanted to make sure that I mentioned here was I do want to make sure that you're able to get a more specific type of function. So what I mean by that is you should also be able to get an a value in front of the factorization. So if you back up to this first example, sorry to go backwards here, but we do want to make sure that the function goes through the points it's supposed to. So if I go like 0, 12, okay, and I'll show you on a graph how that would work. So if it goes through 0, 12, or this particular function goes through 0, 12 also, all right, then we're going to be able to get an a value right here. There should be an a that goes right there. So to get that a value, we're going to put 12 in for f of x or y. We're going to put a, and we're going to put 0 in for x. So 0 plus 3, 0 minus 1, and 0 minus 4. So what we get is a pretty easy, simple equation. It's just going to be 12 equals, and in this case, it's going to be 12 equals negative 12a. So therefore, we had a, which is the stretch factor, the vertical stretch factor. A in this case is going to be 1. All right. So if we graph this on our calculator on Desmos, it would already go through 0 to 12. We don't really need to worry about there being an a value. Okay. In the second one, again, it's also going to be 1. And the reason I'm doing this is because it's going to become more important later. But this one is also going to be 1. So here, let me go down here. So if you want to go through 0 to 12, you would be able to put in, I want to get 12. I want an a value that's going to be 0 goes in for x, 12 comes out for y. So this will give me an a value. That's a. Here, we'll do that one more time. So 0 equals, sorry, I'll get it right this one. So 12 equals a. We got 0 plus 2 squared, 0 minus 1, and 0 minus 3. Okay, so if you look at that carefully, you get 12 equals, and then you'd have what, 4 times -1 times -3. A goes there, so it's a pretty simple equation. 12a equals 12. So that means a would be 1, of course. So we can stick a 1 right in front, right there where a would go. All right. Now that last one that we just did, I believe you'll get -1. Notice that it opens down, basically, we would say. So for this one, here, I think I got some space right here. So this one needs to go through 0, 4. That's 0, 4. Okay. The reason I'm picking 0, 4 is just because it's a really simple, easy point. And I don't really have any other points that I can go on that are given to me. So here I'm going to go right down here. So I'm going to say when y is 4, y-intercept, then 0 for x, 0 plus 2 squared, 0 plus 1, and 0 minus 1, and that's cubed. So what you would end up with then is that 4 equals 4 times 1 times, and that would be negative 1. So basically that would mean that 4, and I did forget the a in, so the a would go here. There's a, there's a. A is the value that would go right at the front. Right? So then if you solve that, for a, you would get that 4 equals negative 4a. So a, of course, would equal negative 1, which is why it opens down. Okay? But just know we will, at some point in time, have different stretch factors or reflection as well. All right, so now let's go ahead. So finding x-intercepts, there's going to be a few different ways to do it. Calculus is going to be the way that you'll eventually be able to find x-intercepts. So let me just kind of walk you through the calculator way of doing this, just to make sure you're clear, and then you can pretty much do it with anything, or you can also use Desmos, which would be a much simpler way, but you're not always going to be able to use Desmos. All right, so if you want to do it this way, now, let me get my graphing calculator, TI version. All right, so on my TI calculator, given the function, graph it, and then find the zeros. And this is one where you're not going to be able to do that without really using the tool of the graphing calculator, because otherwise, yeah, it's just going to be kind of hard to find those x-intercepts or zeros. So let's go ahead and put the function in. So we're going to clear that out. We'll do y equals x squared minus 3x minus 7. I would do a standard window, zoom 6, and zoom 6 will get you most of what you need. What we're looking for here is our x-intercepts. So I'm going to just go through the steps here. Press second, trace to get to the calculate menu. Yeah. So I'm going to do this. Press second trace. Second trace to get to the calculate menu. Once you're on the calculate menu, you're going to select 0, the 0 function. So that's going to be number 2. Enter. All right. So once you do that, then it's going to ask you to do left bound, go left of the 0 and press enter, and then right bound, go right of the 0. So left bound, so let's do the left x-intercept, the one on the left side here. Press enter, you'll see a little arrow. Go to the right of that x-intercept, press enter a third time, and there's the x-intercept. So you'll see y equals 0. Sometimes it's a little confusing when it doesn't look like y equals 0, but that should be the first one. So make sure you go through and you try that, and it works for you. All right, so one of our x-intercepts is right there, about negative 5.5, negative 1.5 or so. So we're going to do that again. We're going to repeat this process for the second x-intercept. Okay, and then we'll be able to identify the intervals along the way. And then we'll use Desmos for a couple of these at the bottom just because that'll be a lot easier. All right, so repeat for any others. The 0 will be shown on the screen. All right, so let's do the second calc. Go to 0. Go to the left side of that 0 on the positive x-axis over here. I'll do left bound there. I'll do right bound here. Press enter, and there you go. Now, this one's a little weird. Your calculator may or may not do this, depending on the problem. But the way your calculator is programmed, sometimes it will not give you 0 for y, but it's just a different version. So, there we go. Let me look at both of those. Okay, so if you have this, it's okay, it still works. So this, so x, this is the x value, y is 0, this is the x value. that is supposed to represent 0. It's just a really small number, scientific notation. Unfortunately, that's kind of the way that it works, right? So my zeros are negative 1.54 and then what? Positive 4.54. So again, we kind of see that symmetry as far as the same values repeating themselves, one on the positive x-axis, the other one there is on the negative. Okay, so let's go ahead and do the intervals, and then I'll give you the answers for the rest of it, and you can decide how you want to do it yourself. All right, so positive interval is going to be from negative infinity to negative 1.5. We'll do negative 1.54. Okay, so as I look at that graph that I just got on my calculator, negative infinity to negative 1.54. It's also going to be positive on the right side, so that unites or union with 4.54 to infinity. All right, so that right there is my positive interval. Okay, the negative interval is just the interval in between, so it's negative in between negative 1.54 and positive 4.54, like that. All right, there we go. Okay. So now you can do that. Desmos is also a very easy, simple tool. So I'll do one of these with Desmos so you can kind of see that. And the rest of them, I'm just going to go ahead and put the answers up here. And then you can ask me if you have some questions or need any more help doing these. But I would definitely at least try a few just to make sure that you're really confident in what you are doing. All right, so let's do this next one here with a Desmos calculator. And then we'll kind of wrap things up. All right, so this one is a cubic. So we could have 3x-intercepts depending on the problem. So I'm going to do f of x. I'm going to do x to the third. I'm going to do 2x squared. I'm going to do minus 5x minus 4. There we go. So my Desmos calculator will give me the x-intercepts real easy there, there, and there. Okay, so let me go ahead and take a quick little picture of that and save it over here so it's saved in my notes. And we'll kind of go from there. There we go. All right, so there's my x-intercepts for that particular cubic function. Okay, there we go. All right, and you can kind of see where the function goes from there. So I'll go through this one, and that was pretty simple to do with Desmos, I think. So now the zeros are going to be at negative 3. I'm just going to call that negative 3.18. And since there's so many of these, we're not going to round to a lot of decimals. So negative 3.18, then we'll say negative 0.68. And then we'll say 1.86. All right, now intervals. Let's see. It is positive between these two x-intercepts right here. There's my positive interval right there to right there. So that's going to be from negative 3.18 all the way over to negative 0.68. That's the only positive interval that we have. And let's see, the negative intervals then will be the other two. Over here, it's negative. And wait, we have one more positive interval. I take that back. Over here, it's also going to be negative. And then right here, it will go positive there. So I'm going to unite that and say 1.86 to infinity, because that also is positive. Okay, so there's two positive intervals united and then two negative intervals united. First negative interval goes from negative infinity to negative 3.18. Second negative interval will go from negative 1.8, looks like that's, to It's going to be negative 0.68, sorry, to 1.86. There we go. Okay, so those would be my two there. All right, I'm just going to write down these next ones, and then if you want to go through them yourself, that would be great. I would highly recommend that you do that. And then let me know if you have any questions or want to go through any of those. I certainly would be willing to help you with those. Okay, so this fourth degree over here, your zeros are going to be negative 1 and 1.59. Your positive interval will be from negative infinity to negative 1. And unite that with 1.59 to infinity. And then your negative interval will be just the space in between if you were to look at that graph, negative 1 and 1.59. Okay, moving on. Okay, two more examples here. Let's see, this negative x to the fourth is going to have zeros at negative 1.74, negative 0.42, 1.48, and 3.69. Interval, positive interval, first one is going to be from negative 1.74 to negative 0.42. Unite that with 1.48 to 3.69. Okay, and again, I'm just writing down the answers. You would definitely be looking at the graph as you do this, so I don't want you to think I'm just getting this off the top of my head, because that's not true. I just already did it, and you don't have to do all of these, but I certainly would say you should check your work on a couple of them just to make sure you know how to use graphing calculators and decimals. Okay, so this one, the negative interval has three parts to it. Negative 0.42 there, 1.48 there. One last interval at the end, 3.69 to infinity. Okay, one more. Last problem here. Zeros are at negative 1.41, positive 1.41, and negative 1. Interval, positive interval is negative 1.41 to negative 1 and 1.41 to infinity. And the negative interval is going to be negative infinity to negative 1.41 union negative 1 to 1.41. All right, so that's all we have for that particular section. Next time we'll start off with the next continuity, discontinuity limits, or intermediate values. But that will do for what we have to do now. All right, I'll see you guys next time.